So let us talk about a particular scenario where we have got a particular network, let's say, broken down into two subnetworks. So we have got something like this, and we are trying to break it down into, let's say, two equal sized subnetworks, right? So let us consider that the left hand side and the right hand side are equal sized subnetworks. So this network, let's say, is identified by the CIDR of 192.168.0.0/26. Right? If this network is identified by the CIDR 192.168.0.0/26, that will immediately mean that we have got how many, what is the size? So once again, let us find out the formula. X equals to 32 minus log base 2 and then size. Now here we know that our X is 26 equals to 32 minus log base 2 size. And therefore, we can say that log base 2 and size equals to 32 minus 26, which happens to be 6. Therefore, the size is going to be 2 to the power 6, which gives you the result of 64. So this is the result that we can come up from this particular formula. So from the CIDR. From the CIDR, using the formula, we can come up till here that the size is going to be 64. Now, if the size is 64, what is the starting and the ending IP? Now, the starting IP we already know from the CIDR is going to be 192.168.0.0. Therefore, the ending IP, or let's say the entire address space for this particular thing, is going to be starting from 192.168.0.0 till 192.168.0.63, because that is altogether giving you 64 IP addresses. So if we are planning to break down into two equal size subnets, then definitely the first one should have 32 IP addresses, the second one should have once again 32 IP addresses. So the IP addresses starting from 192.168.0.0 ranging till 192.168.0.31, that should be the first half of the subnetwork, or let's say the first subnetwork. And the second one is going to be starting from 192.168.0.32 ranging till 192.168.0.63, because that is the second half of the IP address pool, right? We are breaking into equal two parts. So now comes the question, what are the CIDR of each of these individual subnetworks? So this particular subnetwork is starting from 00 going till 31, which gives us size of 32. Therefore, we can calculate the X with the formula 32 minus log base 2 and 32, which is basically nothing but 32 minus 2 to the power 5 is 32, therefore 5, which is equal to 27. Therefore, the CIDR happens to be the starting IP, which is 192.168.0.0/27. Similarly, over here, if we calculate, now we know that the size is once again 32 itself. Even though the starting IP is changing, the size is 32. Therefore, the X value is going to get 27 itself. So therefore, the CIDR over here is going to be 192.168.0.32, which is the starting IP of this particular subnetwork, slash. That is how you figure out what is the CIDR of your individual subnetworks. So therefore, the entire network was 192.168.0.0/26, and your subnetworks are going to be 192.168.0.0/27 and 192.168.0.32/27. So now there is a particular observation I want you to make from here. The observation goes like this: if X value increases by 1, size decreases by half. So when the X value changed from 26 to 27, the size became half. If X value decreases by 1, size doubles up. When the X value is 27, the size is 32 altogether, over here or over here in both the places. And when the X value becomes 26, that is decreased by 1, the size is doubling up. The size has become 64. So now the question comes that why do you break a network into multiple subnetworks? What is the purpose behind it? The purpose behind it is that, let's say you want a different kind of routing. You want a different kind of routing settings in both the parts of the network, right? Still, you want to maintain one thing, the fundamental definition of network, which says that all the devices that are participating in a network should be able to communicate to each other. I mean, that is what a network is. The devices, they communicate with each other and they are taking together is building a network. So therefore, if this particular network has to be a real network, it has to support multiple devices who are present into multiple subnetworks or multiple parts of this network communicate with each other. If it does not do that, it will not be even termed as a network. Let's say we have a server over here, right? This blue colored thing is a server. We have another server over here, and we have, let's say, one single server over here. So these two servers, the server 1, server 2, and server 3, they should be able to talk to each other. How do they do so? Now, when you make different subnetworks, the thing that you get is a different set of routing policies. You get a individual router. One router is supporting this network, one router is supporting the other network. But one particular thing is still same in both the things, in both the routers, is that both of them know how to route to the entire network. This router can also route here, this router can also route here, and the same router can also route here. Similarly, the other router can route here, can route here, and also can route here. In fact, if you try to introduce a new device over here, both the routers will be able to route that one, irrespective of which subnetwork that exists. So if these two machines, let's say machine 1 and machine 2, tries to communicate to machine 3, now these two machines are reporting to which router? The router that is in their subnetwork. So even though that has got a connection with this router, but it will be reporting to this router. So machine 1 tries to go to machine 3, or machine 2 tries to go to machine 3, they'll be talking to this router, and the router has got a connection with machine 3 also, so it can very easily take the communication channel, take the matter that the machine 1 tries to communicate to machine 3 from 1 to 3 through the router. That is possible. Let's say machine 3 tries to reply back to router 1. How does it do so? It can do it from through the router 2, this router. Machine 3 comes to this router because it is reporting to this router, that is the router of its subnetwork, and we can see there is a particular connection to tell this router. So the communication that machine 3 wants to do with machine 1, or let's say machine 2, it can very easily do. So both the routers can route to the entire network. So you still do not violate the basic principle which says that any network, all the devices, they can communicate to each other, right? Keeping the fundamental principle intact, that is, it can route to the entire network, you can keep on adding different routing principles to each of these routers. Let's say, for example, I want these two machines to reach the internet. When you want a particular machine to reach the internet, you need the internet gateway for that. Now, internet gateway takes your information. If you have one, it takes your information that you're trying to pass to the router to tell the internet. If you have to reach the internet, now there are many things. You need a public IP address and all those things. We'll come to that later, but just think about it. If you connect your internet gateway routing with this particular router, and you do not do this with this particular router, even though they are present on the same network, these two machines, machine 1 and machine 2, will be perfectly able to reach the internet, where machine 3 will be completely unreachable from the internet as well as to the internet, right? So you can apply different kind of network settings in this particular thing. The next session will be completely on the understanding of how to set up these things on AWS cloud, and how does internet gateway actually get connected with the router, and we'll be trying to set up. So next session we move on to AWS cloud completely. So this was the main prerequisite that you need to know at least in order to start with the AWS cloud.